All right, so this is your STAAR science reference material sheet that you will be getting on the STAAR test. So it's very important that you actually know how to use this thing. If you get a math problem, it is going to be using one of these three formulas here. The only one that you will likely have to manipulate is going to be this formula here. A good thing to do is when you get this is go ahead and identify that force equals mass times acceleration. This is going to be the second law. So the second law of motion is a relationship between force, mass, and acceleration. So it's a really good thing to go ahead and tell yourself that that is the second law, so you can differentiate between the law of inertia, which is the first, and the law of action and reaction, which is the third. And so if you don't know how to do the opposite of the function here, so either dividing by m or dividing by a to isolate those variables, you can simply just use this little triangle. So you draw the triangle, draw the t, and then you would put f, m, and a. And how you use this is you just cover up the variable that you want to solve for. So if you wanted to solve for a, it would be f over m. And if you want to solve for m, it would be f over a. So you could then go ahead and write those out. M equals f over a, and a equals f over m. And so those three, along with the speed equals distance over time and the density equals mass over volume, are going to be able to allow you to answer any math problem that you are given. All right, so if we flip this over onto the other side, we'll go ahead and look at the periodic table and do a little brain dump here. You might remember this called games. So we'll go ahead and write that mnemonic there at the top of the page to remind us of what we need to remember. And so the first thing that we're going to do is we're going to draw a group and a period. So a group, remember, these go up and down. So you can go ahead and label that as a group. Remember, it has the word up in that name, group. And so groups are going to be equal to the number of valence electrons. And we then have periods that go left to right. So I'm going to go ahead and circle period number 3 that goes all the way across the gap here. Right? And so we can label this as a period. And these are going to be equal to the number of rings around the nucleus, or energy levels. So we have G and E already checked off. Groups are equal to valence electrons. Periods are equal to energy levels going left to right. And so when we look at the energy level numbers, 1, 2, 3, 4, 5, 6, and 7, those are the number of energy levels. But when we look at the group numbers, we can only make predictions about group number 1 and group number 2. These are the bad boys of the periodic table. We cannot make predictions about them, but we can say groups 13 through 18, they don't have 13 through 18 valence electrons. They only have 3 through 8. So you can look at the second number, drop the 1, and that will tell you the number of valence electrons. So 1, 2, and 13 through 18 have 1 through 8 valence electrons. The next thing that we're going to look at is A, which stands for the atomic number. And so the atomic number, this number at the top right there, that's always going to tell you the number of protons. That's why we say it determines the identity. And if you know the number of protons, because these atoms are neutral, you also know the number of electrons. So that's the A part of the 8-man formula. And then this number right here, the atomic mass is given by the number of protons plus the number of neutrons. So if you were asked to calculate the mass, you know that the protons plus the neutrons is going to give you that number. And so if you want to know the number of neutrons, you take this number, and that's where we get the m minus a is equal to n. So if you want to know the number of neutrons, you use the Mann formula. Take the number of protons plus neutrons, subtract the protons, and you get neutrons by themselves. So there's A. The next thing is going to be M, which is metals, nonmetals, and metalloids. And so you need to understand, to separate the metals from the nonmetals, you're going to shade the metalloids. And you're always going to start by shading the first one that sits on the staircase. And then the next two that go above and below, the next two, and the next two. And so all of these guys right here are what we call the metalloids, with properties of both metals and nonmetals. Everything on the right is going to be a nonmetal, and everything on the left is going to be a metal, except for hydrogen over there, which is why I like to circle him, just to remind myself hydrogen is not a metal. And so there's the metals, nonmetals, metalloids. And then the last thing that we're going to do here is we're going to identify which of these groups is stable and which of these is most reactive. So this group right here, we know is the only stable group. And why is it stable? Is because it has an octet, right? And so this is the only stable group, and thus over here is going to be the most reactive of the metals rather, because they are the closest to having an octet without being there, and thus over here are also going to be the most reactive of the nonmetals. All right, and so that is